In this question, we will determine the nth degree Taylor approximation of f of 10 about x equal to 8, where f of x is given as square root of x plus 1. So here we have three parts. That is, we have to find the first degree Taylor approximation of f of 10 about x equal to 8, and similarly we have to find the second degree Taylor approximation of f of 10 about x equal to 8, and finally we have to do it for the third degree Taylor approximation. So let's see how to do it. To find the Taylor approximation, we will be placing this formula where Tn represents the nth degree Taylor approximation, and this is equal to f of c plus f prime of c times x minus c raised to the power of 1 divided by 1 factorial plus f double prime of c, which is the second derivative of f of x centered at c, multiplied with x minus c squared divided by 2 factorial plus f prime of c, f triple prime of c multiplied with x minus c cube divided by 3 factorial plus and so on till f nth degree nth derivative of f of x centered at c multiplied with x minus c raised to the power of n divided by n factorial. So this is the primary formula which we'll be placing to determine the values of t1, t2 and t3. So to utilize this formula, we need the values like c, the derivative of f of x at c, that is f prime of c, f double prime of c, and so on. So let's identify the c from this question. The c is centered the point which is x equal to 8. So we can consider c equal to 8. Okay. So we need to find the first derivative, second derivative, and third derivative because we are going to find t1, t2, and t3. So let's see how to do it for t1. This is the first degree Taylor approximation. We'll be finding f of 10 about c equal to 8. So to do this, we need the first derivative. So let's take the f of x. We have been given the f of x is equal to square root of x plus 1. So this implies I can differentiate both sides. Then I will be getting f prime of x is equal to the first derivative of square root of x plus 1 is 1 divided by square root 2 times of square root of x plus 1. You can consider this as square root of x plus 1 as x plus 1 raised to the power of 1 by 2, and when you apply the power rule of differentiation, you put the power in front and reduce the power by 1. So this will give you 1 by 2 minus 1. So this is basically negative 1 by 2, which I have put it in the denominator as square root of x plus 1. So this is f prime of c. This is f prime of x. Now we will find f prime of c, which is f prime of 8. So this means I have to substitute x equal to 8 into this, and when I do that, I'll be getting 1 by 2 times of, in place of x, I'm going to put 8. So this becomes, this will become 8 plus 1, which is square root of 9 is equal to 3. So 3 times 2 is 6. So basically this is 1 by 6. This is f prime of 8. We will also have to find f of c. That's the first value we should have found out. So let's find f of 8. So to find f of 8, all that you have to do is plug in x equal to 8 into f of x. And when I do that, I'll be getting square root of 8 plus 1. Once again, I put 9. Since I know that the square root of 9 is it is 3, so I'm putting it as 9. So it's basically square root of 8 plus 1 is square root of 9. This is equal to 3. So we have two values, f prime of 8 as well as f of 8. So we can find the f of t1. So let's first write down for t1, which is in t1, f of x is basically equal to f of c plus f prime of c times x minus c power 1, that is raised to the power of 1 divided by 1 factorial. Now you can replace c as 8. So I'm going to replace this c as 8. Everywhere I see, I'm replacing it as 8. So this is how it looks like, which means I have to add f of 8. I know f of 8 is 3. I'm going to substitute here plus f prime of 8, which I have found out here, which is 1 by 6. So 3 plus 1 by 6 times of x minus 8. raised to the power of 1, which is basically x minus 8, divided by 1 factorial is just 1. So let's get this simplified. So we are going to get 3 plus 1 by 6 times of x minus 8. This is basically f of x, the first degree Taylor approximation. But since we have to find out about for f of 10, we can replace x as 10. So plug in x equal to 10, which means we'll get the first degree Taylor polynomial approximation of f of 10 about x equal to 8. This is equal to 3 plus 1 by 6. Replace x by 10. This will become 10 minus 8. So I can put this as 2. This is going to be 3 plus 1 by 6 times 2. This is equal to, when you simplify, you'll be getting 3 plus, this will be 3 plus 1/3. So this is equal to basically 10/3. So this is the answer for part 1, which is the first degree Taylor approximation of f of 10 about x equal to 8, that is 10 by 3. In the same way, we can now do the Taylor approximation, that is a second degree Taylor approximation of f of 10 about x equal to 8. So first let's write the formula or the f of x. So therefore this f of x is equal to f of c plus f prime of c times x minus c to the first power, which I just keep it as it is, 1 factorial, plus f second double prime of c times x minus c quantity square divided by 2 factorial. So as you can observe, this is basically T1. This is basically T1, which we have already completed. So we don't need to do this. We just have to do only this part. So let's do this part. For that, we need to find the second derivative of f of x. So let's copy the second derivative of f of x. This is the first derivative, that is f prime of x is 1 by 2 times of square root of x plus 1. I'm going to copy that here. So therefore, we have the first derivative of f of x is equal to 1 by 2 square root of x plus 1. This can be written in exponent form as 1 by 2 x plus 1 raised to the power of 1 by 2. So this will be convenient for us to find the second derivative. Now let's find the second derivative, that is f double prime of x. I'm using this form. When I apply the power rule, I put the power in front, that is negative 1 by 2. Then x plus 1 raised to the power of, I have to reduce it by 1, reduce the power by 1. So this will be minus 1 by 2 minus 1. So when I simplify this, I get 1 by 2 times minus 1 by 2 is negative 1 by 4 times of x plus 1. Minus 1 by 2 minus 1 is basically minus 3 by 2. So this could be written as positive powers. So this is negative 1 by 4 times of x plus 1 raised to the power of positive 3 by 2. So this is basically f double prime of x, but we need f double prime of c, which is f double prime of 8. So let's also calculate that. It's just that we have to substitute x equal to 8 into this. And when I do that, I get negative 1 by 4 times of 1 by 8 plus 1 raised to the power of 3 by 2. So let's get this simplified. This is minus 1 by 4. 8 plus 1 is 9. So this is basically 9 power 3 by 2. So let's calculate the value of 9 power 3 by 2. Let me do it here. This is equal to 9 power half raised to the power of 3. So 9 power half is basically square root of 9, which is 3. So which means 3 cube. 3 cube is 27. So I can replace this as simply 27. And 27 times 4 is 96. So this is basically 1 by 96. So we have found out the value of f double prime of 8. Now let's calculate this quantity, that is f double prime of c x minus c squared by 2 factorial. We are only calculating that part, that is f double prime of 8 times x minus 8 quantity square divided by 2 factorial is basically 2. So I can just leave it as 2. So this is equivalent to f double prime of 8 we just found out, that is negative 1 by 96 times x minus 8 quantity square divided by 2. So this is the part which we need for T2. We have found out. Let's now find out T2. T2 is basically T1 plus this quantity. So let's do that. We are going to find a T2 into 2. We are finding F10, and this is equal to T1 plus this quantity centered at x equal to, we have to replace x equal to 10. So therefore this will become minus 1 by 96. X equal to 10 means 10 minus 8 quantity squared divided by 2. Let me replace the T1 as well, which we have found earlier. T1 is 10 by 3. So I can replace this as 10 by 3. So we just have to replace, simplify this. This is equal to 10 by 3 minus 1 by 96 times of 10 minus 8 is 2. 2 square is 4. So then we divide 4 by 2, we get 2. So we can either plug this or we can simplify this. This is, I can reduce this as 48. So this is 1 by 48. So this comes out to be 48. 160 minus 1, which is 179. I'm sorry, 159. This is coming as 159 by 49. I'm sorry, I think I could have made a mistake over here. So let's go back and check. This one is 27 times 4. This is not 1 by 96. This is 108. This is 108, 108. So we just have to replace this quantity. So let me get this erased. We can completely erase from here, and this as well. This is 108. So now this comes out to be 10 third minus of 1 by 108 divided by times 2. So this will be 54. So we get 10 third minus of 1 by 54, and this is equivalent to 179 by 54. So this is the value of f of 10 about x equal to 8. That is the second degree Taylor approximation. We are now just one step away from completing this question. That is, we have to find the T3. T3 is basically the third degree Taylor approximation. So this one is T1 plus T2 plus, using the Taylor approximation formula, with this f triple prime of c multiplied by x minus c to the third power divided by 3 factorial. So let's calculate this portion. Once we know this portion, we can evaluate this T3. So this will be T2. It is not T1 plus T2. This is just T2 plus this quantity. So let's do this. We need the third derivative of f of x. So let me write down the second derivative first. F double prime of x is, you can copy it from what we have done before. So we have it here. This is our second derivative, that is negative 1/4 x plus 1 raised to the power of 3 by 2. I'm going to write down here negative 1/4 x plus 1 raised to the power of 3 by 2. Now we find the third derivative, that is f triple prime of x. This is equal to minus 1/4. This can be written as minus 1/4 plus 1 raised to the power of minus 3 by 2. So when we apply the power rule, we'll be getting minus 3 by 2 x plus 1 raised to the power of minus 3 by 2 minus 1. This is equal to minus 5 by 2. So this comes out to be, when we simplify, 3 by 8, it's a positive 3 by 8 divided by x plus 1 raised to the power of 5 by 2, positive 5 by 2. We can find f triple prime of c. If you replace c by 8, we get 3 by 8, 1 by 8 plus 1, which is 9 power 5 by 2. So let's simplify 9 power 5 by 2. This is equal to 9 power 1 by 2 raised to the power of 5. 9 power 1 by 2 is square root of 9, which is 3. So this represents basically 3 power 5. So I can substitute here. This is 3 by 8 times 1 by 3 power 5. I can reduce this power once. This is 4. So this is basically 1 by 8 times of 3 power 4. So let's have it like this. When we substitute into the formula, maybe we will get some terms simplified. So now let's find out this quantity, that is f triple prime of c multiplied with x minus c cube divided by 3 factorial. We are evaluating this. So f triple prime of 8 multiplied with x minus 8 raised to the power of 3 divided by 3 factorial is basically 1 times 2 times 3, which is 6. And this is equal to, we found out f triple prime of 8. I'm replacing it here. That is 1 by 8 times of 3 power 4 multiplied with x minus 8 cube divided by 6. But since we have to calculate f triple f of 10, we now find f of 10 for this. So I'm going to erase some part of it. We erase this. Okay. So we have to find f of 10. This is equal to t2 plus this quantity, that is 1 by 8 times of 3 power 4 times of, we have to replace x by 10. So when we do that, we will get 10 minus 8, which is 2 cube by 6. So let me replace t2. We have found out the value of t2 as 179 by 54. So you can replace it over here. 179 by 54 plus this is 2 cube is 8. So these two will get cancelled. And then we have 1 by 3 power 4, which is 81 times of 6. Okay. So when we simplify this, we'll be getting 3.317. So this is basically T3. Now let me put all the values in terms of decimals. T1 is equal to, that is we had 10 by 3. So this is basically 3.333. And similarly T2, we got 179 by 54. So this is approximately 3.315. And finally T3, we got it as 3.317. So this is how we have to do the Taylor approximation for a polynomial.